Hello, Professor Schunk. Welcome to the Department of Chemistry of the University of Padua. We look forward to your talk now because we are very curious about, for example, which will be the role of artificial intelligence in our research. Should we change our way to collect the data, for example? Should we also rely on the wrong experiments? What do you think in this sense?
I think it's a very important question that concerns me a lot. Yeah. So first of all, thanks for the very kind invitation and the kind reception. I appreciate that a lot. So when it comes to the use of AI, I personally think it's all about data and not so much about the algorithms at present. So we have all of these algorithms available in different fields of science. And for us in chemistry or in material sciences, I think the focus should be, can we basically apply those algorithms to problems that we have in material science. And a lot of the work should go into structuring our data, making our data available and democratizing our data. And for me, there are two things that are very important, and those we need to solve as a community. The first one are data standards. Yeah. How do we structure our data? How do we make best use of available ontologies, and where do we need to add to the ontology space? And the second thing is, which metadata standards do we use and how do we implement them into our structured data? Yeah. I think that is something where the community needs to arrive at a point where we have a community-wide agreement. There can still be a competition of standards. I think that is what we see in many fields, but that is point number one. For me, the second step is then, if we have those data and they are, so to say, AI ready, what can we do with them and how can we bring things forward? Yeah? So what I've brought for today are a few examples where we tap into resources of structured data which are already publicly available and how we use them to help with our experimentation to really propel development pipelines.
Okay. And from a different point of view, what do you think about our experimental studies? Will they be converted into simulations and theoretical studies assisted by artificial intelligence?
I think for me the general question is more about effectiveness and effectivity. I mean, what we as scientists have always tried to do is to be very effective, so to say, good use of our resources. And I think by using historical data or annotated data, we have a better chance of avoiding experiments that have already been done in the past and have not been successful. So it's kind of like a blending of what has happened in the past, and we blend that into the future, and we can make better use of our resources, and we can be faster, so to say, and also build on what other people have been done. So what we have been discussing basically during this morning sessions was already, do we still need validation experiments? And I think we need these, particularly also in different contexts. We may rely on different batches of materials, so these still have their place. But finally, by the end of the day, for me, we will certainly have less experiments, but I assume that those will be better in the sense in creating more output. Yeah. And I think that's the important point.
Very interesting. Okay. And what do you suggest from the teaching point of view? What should not miss in our curriculum in order to make students to be able to have access to competing techniques and methodologies?
No, this is absolutely one of the very important fields, and for me also having a chair at University Leipzig, this is something which concerns me a lot. I mean, traditionally, particularly in European universities, we have all of the different faculties. And I think we need to soften the silos. And in certain spaces, we may also think about redesigning what we see as faculty silos and start to build schools, basically, which make an interconnectivity in between the silos. Me, as a chemist and material scientist, I'm not a specialist in AI algorithms or programming. I need to rely on resources in advanced mathematics, applied mathematics, software engineering, and people who know about code and data structures. And I think this is basically the connections which we need to make. And together with the experts in the different fields, we need to extract how can we bring this to our community of students and how can we basically adapt this into a curriculum and a culture of learning basically, which keeps us also as individuals plus the students which are upcoming at the top-notch level of science.
Okay, very last, very quick. You were mentioning the need to become a digital community.
Yeah.
What would you suggest for a department like?
Yeah. I think it's a cultural question. See, can we assimilate basically the methods of digital chemistry fast enough and good enough in a whole department to basically foster this cultural transition? For me, it's not so much about the technology because the technology is there, but it's really making sure that everybody in a very democratic way has the chance to get the best out of the technology, and I think that can propel science very much forward in the department.
Okay, thank you very much.
Thanks a lot, Jens.
Okay.